Hello students. Now in this video we're going to learn about increasing and decreasing functions. Now this is need to learn this before we actually go and start learning about local maximum and local minimum and stationary points, point of inflection, everything. Okay, so the first thing is this is the basics. Now what do you mean by an increasing function and what do you mean by decreasing function? Let us see that. So let me draw a graph for you. Let me draw the y-axis. Okay, a vertical line. This is y-axis. Let me draw the x-axis as well. Okay, so this is x-axis. So let me draw a part of the curve. Let's say a curve is like this. Okay, that is this curve. Let me take a point here on x-axis. Let's say this is x1. Okay, this is x1. So let me draw a vertical line and let me draw a horizontal line. So we all know that this will be f of x1, isn't it, students? Okay, so let me take another point on x-axis. So let me take another point. Let's say I take x2. Now let me draw a vertical line, and from there let me draw a horizontal line. So now this point will be 0 comma f of x2. So f of x2. Okay, now we can see that x1 is smaller than x2, isn't it? We also note that f of x1 is also smaller than f of x2 in value. So here x1 is smaller than x2 gives me f of x1 is also smaller than f of x2, isn't it? Good. Let's say let me take another point. Okay, so let me take, let's say, x3 here. So let's say this is x3. Let me draw a vertical line. Sorry, it doesn't look vertical, but fine, I hope you can manage. And let me draw a horizontal line. So this point you see here is f of x3. Okay, now let us compare x1 and x3 now. We can see that x1 is smaller than x3, and it implies that f of x1 is also smaller than f of x3, isn't it? And let us say x2 is smaller than x3, but we can also see that f of x2, this is f of x2 here, it is also smaller than f of x3, right? Okay, now let me ask you a question. Let's say let me erase this line, let me erase this and this as well. Okay, let me erase these values as well. Okay, let me complete the y-axis. This is the y-axis, this is the x-axis. Let me complete the curve also. So this is the curve. So, okay, now let's say let me draw a vertical line here. Let's say this is A and another vertical line here. Let's take this is B. Okay, now let us consider the interval a comma b, students. The interval a comma b. I hope you know what it means. This means the set of all real numbers. This means the set of all real numbers between a and b. Okay, now if I take any two values here, let's say I take x here and I take, let's say, y here. Do you think if x is smaller than y, do you think that f of x will also be smaller than f of y? Let's say, for example, I take another point z here. So if y is smaller than z, do you think f of y will be smaller than f of z? Will it be true, students? Yeah, let us check. Say this is x, so this is f of x, this is y, so this is f of y, and this is z, and this is f of z, right? Definitely. So this is true, this is also true. Okay, so let me generalize this statement. Can I say that if I take, let's say, any two values in this interval, like in this, the interval that you see here, let me highlight it, in this interval a to b, if I take any x and y, let's say x comma y belongs to the interval a comma b, such that x is smaller than y. Now, when x is smaller than y, will it imply always that f of x is always smaller than f of y in this interval? Do you think so? That if I take x here, if I take two points on x-axis, if x is smaller than y, do you think f of x will be smaller than f of y? Definitely. This will always be true, isn't it? Now, what does it mean? Okay, let me try to explain it further so that I know you may not be very clear. So let me explain it. Now, you see here, as x increases, what happens to f of x? You can see that this is f of x, isn't it? This is f of x. Okay, let me maybe draw a first new diagram. Let me draw the y-axis, and let me draw the x-axis. So this is x, this is y, and I'm drawing a part of the curve here. And as I mentioned, let me take this as a, and let me take this as b. Okay, suppose let's say x is here, then this will be f of x, isn't it? Suppose if x is here, then this will be f of x. Now, do you see something, students? When you move to the right, x values become bigger and bigger and bigger and bigger, and so does the values of f of x. F of x also becomes bigger and bigger and bigger, isn't it? So when you move to the right, x becomes bigger. Let's say x is 3, 3.1, 3.2, 3.3, 3.4. F of x also becomes bigger and bigger and bigger. So we say this part of the function, this part of the function, this part of the graph is increasing. Why do we say increasing? Because as x values increase, the values of f of x also increase. So I say this part of the graph is increasing. Okay, I hope you are clear. So I will say, suppose if this is f of x, I will say f of x is an increasing function. F of x is an increasing function in the interval a comma b. That means if we consider this interval as x moves to the right hand side, x becomes bigger and bigger and bigger, f of x also becomes bigger and bigger and bigger. Or you can say other way, when x moves to the left hand side, f of x, so x becomes smaller, f of x also becomes smaller. It's like for something like something similar to direct proportion. Okay, so you can say, so this part of a function is increasing function. Okay, so I hope this is clear. So let us now learn about decreasing function now. Okay, now let us consider a part of a graph. I mean a part of the graph of a function, part of a curve. Let's say you see here the black colored one, that's a curve. So this is the curve. Okay, now what happens? Let's take let's say x is here, x is here, x is here. You can see that x becomes bigger and bigger and bigger. But what happens to f of x, students? F of x becomes smaller and smaller and smaller and smaller and smaller and smaller. So in this interval, if x is smaller than y, it means f of x will be bigger than f of y, isn't it? You can see, let's say you take this as x, you take this as y, you can see that x is smaller than y, and this is, so I'm sorry, this is f of x, and this is f of y. You can see that x is smaller than y, but f of x is bigger than f of y. So as I mentioned, as x becomes bigger and bigger and bigger, f of x becomes smaller and smaller and smaller and smaller. Okay, so the other way around, as x becomes smaller and smaller and smaller, f of x becomes bigger. So basically something like a indirect variation, indirect proportion. So what it means is, here this f of x is a decreasing function, or say f of x, let's say f of x is decreasing, f of x is decreasing in the interval a comma b, right? So we say that the function is decreasing. Basically, when I say the function is decreasing, it means the values of the function are decreasing. As x becomes bigger, the f of x becomes smaller. Okay, so this is a decreasing function. So you learned about increasing and decreasing function. I'm sure that still it may not be very clear to you. Don't worry about it. I'm going to give you a lot of examples. I'm going to show you a lot of diagrams to make sure that you understand this concept. Okay, so let us go to the next stage, next step. Okay, now let us look at this diagram, students. Now if we take any point after 3, let's say I here, as you can see, x becomes bigger and bigger and bigger and bigger, and what happens to f of x, students? They also become bigger and bigger and bigger and bigger and bigger. Now this is actually a parabola, so it goes till it extends both sides. Okay, as you can see, as x increases, f of x also increases, isn't it? So I will say f of x is increasing in the interval 3 comma infinity, isn't it? So if as x increases, f of x also goes on increasing. Okay, now what about the points to the left of 3? Now here, as here what is happening, x is becoming smaller and smaller and smaller and smaller and smaller, but f of x becomes bigger and bigger and bigger. So like indirect variation, like indirect proportion, x is becoming smaller, but f of x is becoming bigger. So I will say f of x is decreasing. Okay, but where is it decreasing? You have to mention where it is decreasing. It is decreasing in minus infinity comma 3. So what it means is, if we take, to the left hand side of 3, the function is a decreasing function, and to the right hand side of 3, the function is an increasing function. Okay, to put it in layman's term, if a function looks like this, so it is an increasing function, or a function looks like this, or a function looks like this. All these functions that you see here, they are all increasing functions. Okay, all these functions are increasing functions. I mean, this part of the curve. Now what about decreasing functions? Very simple, they will look like this. Like, for example, like coming down. Okay, like they're coming down from top to bottom. So all these functions that you see here are decreasing functions. I mean, I have drawn arrow here to make you so that you can understand it, but don't draw the arrow. So all these functions that you see here are decreasing functions. Like say they are coming down from top to bottom, they are coming down. So all these functions are decreasing. Right? Good. Now look at this function. It's increasing, and then suddenly it starts decreasing. It starts decreasing, and then it stops, it starts increasing, again stops, decreasing, stop, increasing again. So you can see here, let me draw the y-axis here. Let's say this is y-axis. I'm sorry. Let's say this is y-axis, and let's say this is x-axis. Okay, so let me mark these points. So okay, now look at this function, students. So let's say this is y equal to f of x. Okay, you can see here before 2, that means I'm talking about this part of the curve, the function is increasing, isn't it? As x becomes bigger, so does f of x. They also become bigger. So this part of the curve, that means this before 2, the function is increasing. Okay. What about after 2? After 2, I think this part of the curve, as you can see here, I mean, let me use some other color. This part of the curve, you can see the function is decreasing, isn't it? Okay, again, from here to here, the function is increasing, and then here again, the function is decreasing. This part of the curve is decreasing, and again, finally, it starts increasing. Okay, now what does it mean? It means f of x, so where is it increasing, students? So f of x is increasing where it is increasing before 2, that means I'll write minus infinity comma 2, and it is also increasing between this 5 and 7, isn't it? So between 5 and 7, and it is also increasing after 8, that means 8 to infinity. Okay, where is it decreasing? F of x is decreasing in the interval between 2 and 5, so I'll write in 2 comma 5. It is also decreasing between 7 and 8, so between 7 and 8. Okay, so what do we mean when I say that the function is decreasing in 2 comma 5? It means when I between 2 and 5, between 2 and this is 2 and this is 5, the curve comes down, sort of. Okay, as x increases, f of x decreases. Okay, and what do you mean by increasing function? It's very simple. As x increases, so does f of x. Okay, f of x also increases. So increasing and decreasing function. Okay, let me give you one more example. Okay, now you can see a graph here. This black line is the curve. This is y equal to f of x. Okay, now this is a problem for you. Now please find out, students, look at the graph, spend 1 or 2 minutes and find out in which of the intervals the function is increasing and in which intervals the function is decreasing. So you need to find the intervals in which the function is increasing and also the intervals in which the function is decreasing. So you have 2 minutes now, so you can pause the video and write down the answer in your notebook. Okay, fine. So let me give you the answers. As you can see, let us see how many of you read. Let us see. F of x is increasing in between -2 and 3 and between 5 and 8, right? So you can see here between between -2 and 3, between -2 and 3, the function is increasing. Let's say it goes from top to bottom, and also between 5 and 8, the function is increasing. right? I hope all of you got it right. So what about decreasing? So f of x is decreasing in the interval minus infinity to minus 2. That means here, let me use, let's say, here. So this part of the curve, as you can see, is decreasing. So, and also between 3 and 5. Between 3 and 5, the function is decreasing. So I will write between 3 and 5, so 3 comma 5. And also after 8, the function starts decreasing once more, right? So I will write after 8, that means 8 comma infinity, right? Oh, good. I hope everyone got it right. So let me give you another example. Okay, let us take this line. What about this function, students? Okay, so let this be y equal to f of x. What do you think about this function? Is it decreasing or is it increasing? If it is increasing, where is it increasing? If it is decreasing, where is it decreasing? As you can see, as x becomes bigger and bigger and bigger and bigger and bigger and bigger, f of x also becomes bigger, isn't it? Okay, don't think that the lines are smaller, so how come I can say that f of x is becoming bigger? Very simple. This means, let's say this is minus 2, means this will be minus 1. So we know that minus 1 is always greater than minus 2. So as x becomes bigger and bigger and bigger, f of x also becomes bigger and bigger and bigger. And this is true throughout the x-axis. This is true throughout the x-axis, isn't it? So I will say that this function f of x is an increasing function. That's all. Increasing function. Now you can see that I haven't mentioned any interval, like it is increasing between 3 and 5, or it is increasing between minus infinity and 2, or it is increasing between 3 and 6. I didn't say anything. I just said f of x is an increasing function. That's it. What it means is f of x is increasing. This means f of x is increasing in the interval minus infinity to plus infinity. Okay, so when I say f of x is an increasing function without mentioning any interval, it means it is increasing throughout, right? Okay, let me give you another example. What about let's say this is y and this is x. What about this function, students? You can see. What about this function? This is a straight line, so this is y equal to f of x. As you can see, as x becomes bigger, f of x becomes, f of x becomes smaller and smaller and smaller and smaller and smaller. F of x becomes smaller and smaller and smaller in value. So basically, this function f of x is a decreasing function. Right? So that means it is decreasing throughout. Okay, one more example. Let me draw the y-axis. Let me draw the x-axis. So let me draw the curve f of x equal to x cubed. So it looks like this. What about this function, students? As you can see, as x becomes bigger, or you can say, like, for example, the curve goes like this. So I told you. So it is a increasing function. So throughout, between minus infinity to plus infinity, this is an increasing function, right? So what about let's say, what about f of x equal to minus x cubed then? So it will be a decreasing function throughout. Okay, let me say, okay, let's say till now I gave you a graph I gave you a diagram and I asked you to find the intervals in which the function is increasing or decreasing. But what if I give you just a function? What if I give you, let's say, I just give you f of x equal to x plus 3. Okay, suppose if I ask you this, what about this function? Where is this function decreasing function or is it increasing function? If it is increasing, where is it increasing? So how do you do that? Very simple. What you need to do is you need to plot this function in the Cartesian plane. X plus 3 is basically the y-intercept is nothing but 3. So this is nothing but like y equal to x plus 3, isn't it? Y equal to x plus 3. So it will definitely, when x is 0, y is 3, so it will pass through this point 3. And when y is 0, x is minus 3, so it will pass through this minus 3. So the line, this will look, this will look like this. So as you can see, this is a increasing function. So this f of x equal to x plus 3 is increasing throughout. Okay. What about this function? Let's say, what about f of x equal to minus 2x plus 1? Again, this is a straight line. So what about this function? Is it an increasing function or is it a decreasing function? Or is it increasing and decreasing both in certain intervals? Like increasing in some interval and decreasing some interval. So let me let me plot this function in the Cartesian plane. So we can see that this means y equal to minus 2x plus 1. So the slope is negative, so that means the line will look like something like this. Okay, and the y-intercept is 1, so this is the y-intercept. So that means, let me draw this one. This is 1, so the line will pass through this point. And when y is 0, so I'll get minus 2x plus 1 is 0, so x will be half. That means it will also pass through the point. So let's say this point, half. X is half. So this is how the line will look like. As you can see, this is a decreasing function. So this f of x equal to minus 2x plus 1, it is a decreasing function throughout. Okay. Now we know that if the slope is positive, the line will look like this. And if the line looks like this, it is an increasing function. And if the slope is negative, the line will look like this, then it is a decreasing function throughout. Okay. So one thing you need to keep in mind is, if you get any linear function, let's say f of x equal to x plus 2 or 2x plus 3, y equal to 2x plus 3, or you get y equal to x minus 5, or you get y equal to 5x plus 2. So all these functions that you see are linear functions. So when you plot it in the Cartesian plane, you will always get a straight line. Now you can notice that all these lines, the slopes are positive, isn't it? For this line, the slope is 1. For this line, the slope is 1. For this line, the slope is 2. Again 1, 5. So the slopes are positive. So whenever the slopes are positive, that particular function, linear function, will be increasing function throughout. Same way, when you get a, let's say, a linear function with a negative slope, let's say minus 3x plus 2, or let's say f of x equal to minus 4x plus 1, or let's say minus x plus 3, or let's say 5 minus x. So all these functions, you can see the slopes are negative. So when the slopes are negative, the lines will look like this way. So definitely they are all decreasing functions. So all these functions, all the linear functions with negative slope, all the lines with negative slope, when you actually look at the function, they will all be decreasing function throughout, right? Okay. Now let me give you, I gave you a linear function. So let me give you a quadratic function now. Okay. Consider this function, students, a quadratic function, x squared plus 1. We know that when we actually represent it in a Cartesian plane, you will always get a parabola, isn't it? Okay, what about this function, x squared plus 1? What if I ask you to tell me the intervals in which the function, this function, f of x equal to x squared plus 1 is increasing and also the intervals where this function is decreasing. Now, very simple. What you need to do is, what you can do is, draw the parabola. It's very simple. We know that the x squared plus 1 will look like this, isn't it? I hope you remember the transformations, right? Now tell me, students, so this is, where do you think the function is increasing? Very simple. This area you can see, that is after 0. This is 0, after 0. So the function is increasing in 0 comma infinity, isn't it? Okay, where is it decreasing? Here. Very simple. In this part the function is decreasing. As you can see, it's between minus infinity and 0. So here, that means the this part, the function is increasing. As you can see, the function is increasing, and this part, the function is decreasing. Now you may say, what is it is going up and still you are saying it is decreasing? What I mean is, as x becomes smaller and smaller and smaller and smaller, f of x is becoming bigger. Can't you see that? F of x is becoming bigger and bigger and bigger. So x becomes smaller, but f of x becomes bigger, like opposite, like an inverse variation, as I mentioned earlier. So it is a decreasing function. At that point, I mean in that interval, the function is decreasing. Now here, as x increases, f of x also increases, like direct proportion. So I'm sorry, let me draw it properly. So I said this part, that means this part, the function is increasing, and this part, the function is decreasing. Also, let me give you one more example. Let's say I give you, let's say f of x equal to x. I'm sorry, let me just write it properly. So f of x equal to x minus 2 the whole square. Now you tell me, students, like, where do you think, in which interval the function is increasing or decreasing? Now again, very simple. Draw the graph. Okay, so the parabola will look like this. This is 2. This is how the parabola will look like. So you can see that this side, the function is increasing. That means in 2 to infinity, the function, as you can see, the function is increasing. As x becomes bigger and bigger and bigger, f of x also becomes bigger and bigger and bigger. Now where is it decreasing? Very simple. This part, you can see the function is decreasing. That means here. So the function is decreasing in the interval minus infinity comma 2. Okay, increasing and decreasing functions. Fine. So let me but what if I give you a slightly challenging problem? Okay, let's say I give you f of x equal to x squared minus, let's say, 4x plus 3. Okay, what if I give you this function and ask you to find out where the function is increasing or decreasing? Again, you can see this is a quadratic function. So when I represent this function in a Cartesian plane, I will get a parabola. Okay, but yeah, it is a parabola, but I mean, what will be the vertex of that parabola? Like, how can I plot it? Very simple. I told you earlier, I think I have taught you earlier how to represent a quadratic function in a Cartesian plane. Okay, let us see that. So what we need to do is, there are two ways of doing it. I can either complete the square, or I can do the other way around. Or let us see, let me complete the square. So I get, I write x squared minus 4x. Okay, I hope you remember completing the square. The coefficient of x is 4. What I'll do is I'll divide 4 by 2, always by 2. So I'll get 4 by 2 is 2. Then I'll square 2, which I'll get 4. So what I'll do is I'll add 4 and I'll subtract 4 plus 3. So I get, so this part will give me x minus 2 the whole square, and this part will give me minus 1. So as you can see, x minus 2 the whole square minus 1, which means for the parabola the vertex is 2 comma minus 1. So this is how the parabola will look like. So I'll draw the y-axis, I'll draw the x-axis. So this is, let's say, 2, and this is, let's say, minus 1. So this is the vertex. Now the vertex will be open at the top because the coefficient of x square here is positive. So the parabola will look like this. Good. Now where will it cut y-axis? Very simple. You can see the constant term is 3, so this will be 3. And where will it cut x-axis? Like here and here. Very simple. Solve this x squared minus 4x plus 3 equal to 0. You'll get x as 1 and 3. So this will be 3 and this will be 1. Okay, they are not needed, but in here I thought I can tell you about it. Okay, fine. Now you've drawn the parabola. Please tell me in which interval the function is increasing. Very simple. After 2 the function is increasing. After 2 the function is increasing. And before 2, that is here. I'm sorry, let me use some other color. Let's say, let me use a red color. Before 2 the function is decreasing. Right? So increasing and decreasing function. Good. So always please note, students, the parabola will always, like in a certain interval it will increase, and after that stops, and then it starts decreasing, increasing to decreasing or decreasing to increasing. Okay, but what if I give you something like this? Let's say f of x equal to x cubed minus 2x squared plus x plus 1. What if I give you a cubic function like this? Then how will you find the intervals where the function is increasing or decreasing? It's quite challenging, isn't it? Like you need to know how this graph will look like. In case of quadratic function, it's very simple. It will always be a parabola. But how will a cubic function look like? Okay, then you need to find the x-intercepts, you need to find the y-intercepts, where it cuts the x-axis, where it cuts the y-axis. So it is quite tedious, isn't it? So every time you'll not be able to draw a graph to find. Of course, if there is a graph, it is very easy to find out whether it is increasing, in which interval the function is increasing or decreasing. But every time you cannot draw a graph, isn't it? Suppose it comes in a non-calculator paper. Then you can't draw a graph, and it will take a lot of time for you to do that. So that means we need to have a system, we need to have a way to find, without drawing the graph, we need to find a way so that I can find out, oh, here in this interval the function is increasing, in this interval the function is decreasing. Okay, definitely there is a way. I'm going to teach you right now the same, and we are going to use derivatives for that. Okay, so basically now we come to application of derivatives. Like, how do we use derivatives to find where the function is increasing or decreasing? We're going to find that right now. Okay, now let us look at this diagram. As you can see, this function, this is part of the curve y equal to f of x. Now this function is increasing in the interval 1 to 6, isn't it? You can see that as x becomes bigger, f of x also becomes bigger. Okay, so this is an increasing function. Now, how can I use derivatives here? Okay, let me take, let's say 2. Okay, what is the meaning of f dash of 2, students? What is the meaning of f dash of 2? We all know that f dash of 2 means the slope of the tangent. But which tangent? So what I do is I will draw a vertical line. So I'll take this point. So if I draw a tangent at this point, that tangent will have a slope, and that slope is f dash of 2. Okay, let me take another point. Let me take 4 here. Now again, what do you mean by f dash of 4? What it means is, If I draw a vertical line, I'll consider this point, and if I draw a tangent at this point at 4, this tangent will have a slope, and that slope is f dash of 4. Okay, let me take another point. Let's say, let me take 5 here. So what is the meaning of f dash of 5 now? F dash of 5. It means, let me draw a vertical line. Let me take this point. If I draw a tangent at this point, that means if I draw a tangent at this point, then that tangent will have a, I'm sorry, it doesn't look like a straight line. So that tangent will have a slope, and the slope is f dash of 5. Now let me ask you a question. Can you tell me whether this f dash of 2, the f dash of 2 you see here, will it be positive or negative or 0? Any idea, students? Yeah, it will definitely be positive, so it will definitely be more than 0. What about f dash of 4? It will also be more than 0. What about f dash of 5? It will always be more than 0. Now you might wonder, how can I say confidently that f dash of 2, f dash of 4, f dash of 5, they are all more than 0? It's very simple. I'm using a fact, which is, now f dash of 2, f dash of 4 and f dash of 5, all of them are slopes, isn't it? For example, f dash of 2 is the slope of this line, and f dash of 4 is the slope of this line, and f dash of 5 is the slope of this line. Okay, we know that any line that looks like this, all these lines will have positive slope, isn't it? So obviously all f dash of 2, f dash of 4 and f dash of 5 will always be greater than 0. Always be greater than 0. Okay, so let me ask you another question. Let me erase this. Okay, if I take, let's say, some number, let's say a, between 1 and 6, I'm talking about this one and this 6. If I take any number between 1 and 6, do you think f dash of a will be greater than 0 always? Will it be true, students? So if I take any value, let's say if I take 3.1 or 4.1 or 5.1, do you think f dash of a will be more than 0? Let me cross check. Let me say, let me take a value between 1 and 6. Let's say I take 3.1. Okay, where is 3.1? Let's say 3.1 is here. This is 3.1. Then what is f dash of 3.1? So f dash of 3.1 is nothing but the slope of the tangent. So I draw a vertical line, and from there I draw a tangent. Yeah, definitely this tangent will have a positive slope. This tangent will have a positive slope. So f dash of 3.1 will be more than 0. So definitely, if we take any value between 1 and 6, f dash of a will always be positive. Okay, so this will always be a fact. So if we take any point between 1 and 6, f dash of that point will always be positive. Okay, let me consider this function. Okay, look at this problem, x square minus 4x plus 3. Now I'm going to find out, without actually drawing the graph, in which interval is this function increasing or decreasing. So what I'll do is, first I'll find f dash of x. So f dash of x, which is nothing but 2x minus 4. Then I will equate f dash of x to 0. So f dash of x equal to 0 implies 2x minus 4 equal to 0, which implies x equal to 2. Now what does it mean? That means f dash of 2 is 0. That means at the point 2 you'll have a horizontal tangent. Okay, now I'll draw a real line. I'll mark 2 here. Okay, now what I'll do now is I'll take a value above 2, greater than 2, but closer to 2. Let's say 2.1. Then let me find f dash of 2.1. What will be f dash of 2.1? 2 times 2.1 minus 4. How do you get it? I'm using this 2x minus 4. So I get 0.2 as the answer, which is positive. Right? Let me take another value. Let me take 3. F dash of 3 is 2 times 3 minus 4, which is 2, again positive. Let me take another value closer to 2. Let's say f dash of 2.5. I get 2 times 2.5 minus 4, which is again 1 positive. So in fact, if we take any value above 2 students and put it in f dash of x, you'll always get f dash of x as positive. Always. Okay. Now you need not take 2, 3 values. Just take one value, and if you get more than 0, then you write f dash of x is more than 0 in this interval here. Okay. Let me take a value less than 2. Let me take, let's say 1.5. Let's say 1.5. Okay. Let me find f dash of 1.5. So f dash of 1.5 is 2 into 1.5 minus 4, which is minus 1, less than 0. Let me take another value. Let's say, let me take 1 here. Okay. 1, just 0.1. Okay. F dash of 1 is 2 into 1 minus 4, which is minus 2, again less than 0. Now again, you will find that if you take any value less than 2 students and substitute in f dash of x, you will get f dash of x as always negative. Okay. Now here f dash of 2 is 0, right? Okay. Now if you recall, just a few minutes back we saw that wherever f dash of x is positive, there the function is increasing, and whenever f dash of x, or wherever f dash of x is less than 0, the function is decreasing. That means increasing in 2 comma infinity and decreasing in minus infinity comma 2. Okay, so let us cross check. If you recall, this was the graph that we got. This is y-axis, this is x-axis, and this is the parabola, and this point was 2, right? It's clear, right? You can see that after 2 the function is increasing, so this is correct, and before 2 the function is decreasing, so this is also correct. So it's very, very simple. This is called as the first derivative test. We use the first derivative test to find the intervals in which the function is increasing or decreasing. Okay, let us see one more example. This is a very easy concept. Okay, so let us look at another example. F of x equal to minus x square plus 6x minus 9. So let me find f dash of x, which is minus 2x plus 6. I'll equate f dash of x to 0. So f dash of x equal to 0 implies minus 2x plus 6 equal to 0, which means x equal to 3. So I'll draw a number line. I'll write 3 here. Then what I'll do is, I will take a point, I'll take a value which is above 3, let's say 3.1, and I substitute in the function. So f dash of 3.1 is minus 2 into 3.1 plus 6, I'll get minus 0.2, which is negative. That means f dash of x is negative here. What it means that if you take any value above 3 and substitute in f dash of x, you'll always get negative value. Okay, you can cross check if you want to. Now let me take a value below 3, smaller than 3. Let's say, let me take 2.5. So f dash of 2.5 is nothing but minus 2 into 2.5 plus 6. So I'll get minus 5 plus 6, which is 1, which is positive. So here f dash of x will be positive. So it means if I take any value here and substitute in f dash of x, it will always be positive. And we know that f dash of 3 is 0, isn't it? Now what does it mean? As I mentioned earlier, it's very simple. Whenever f dash of x, or wherever f dash of x is positive, it will be increasing function. So here f dash of x is positive. That means the function is increasing the function is increasing in the interval minus infinity comma 3. And whenever the first derivative is negative, there the function is decreasing. That means it is decreasing in the interval 3 comma infinity. So let me cross check it using a diagram, using plotting. Okay, I'm going to plot this minus x squared plus 6x plus 9. So when you draw, in fact, you will get this parabola. This is 3. You will get this parabola. Okay, as you can see, after 3 the function is decreasing. So this is correct. And before 3 the function is increasing. So this is also correct. Right? Very simple. Let us see a few more examples. Let us see f of x equal to x cubed. Okay. So what will be f dash of x? F dash of x is 3x squared. Then I'll equate f dash of x to 0. So f dash of x equal to 0 implies 3x squared equal to 0, which means x equal to 0. So let me draw a number line. I'll write 0 here. Now let me take a value more than 0. Let's say let me take 0.5. So f dash of 0.5 will be, I think I'll substitute it here. So 3 into 0.5 squared, which will definitely be positive. So here f dash of x will definitely be positive after 0. Let me take a value less than 0. Let me take, let's say minus, normally you should take close to 0, but this time let me take minus 1. So f dash of minus 1 is 3 into minus 1 whole square, again positive. So here also f dash of x is positive. So you can see after 0 also f dash of x is positive, and before 0 also f dash of x is positive. It means that f of x is increasing throughout. That means between minus infinity to plus infinity. It is an increasing function throughout. So let me check whether it is right or wrong. So this is the y-axis. This is the x-axis. So the graph will look like this. As you can see, it is increasing function throughout. So which is correct, right? One more example. Let's say f of x equal to 3x plus 2. Now f dash of x equal to 3. Now normally I'll equate it to 0, but here that's all. I mean f dash of x is 3, which is positive. That means whatever you put for x, like f dash of 1 will be positive, or f dash of 4, because all of them are 3. No, f dash of 1 is 3, f dash of 4 is 3, f dash of 5 is 3, everything is positive. That means this function is increasing throughout. Increasing throughout. So let me cross check, draw x-axis, y-axis. Okay, so the line will look like this. So this will be 2 and this will be minus 2 by 3. So again you can see this is a increasing function, right? It's very, very simple. Fine. The last two problems of this session, of this video clip. Okay, now look at this cubic function, students. I want to find this function in which intervals. I'm going to find the intervals in which the function is increasing or decreasing. Okay, so first step is find the derivative. So f dash of x, which is nothing but 3x squared minus 27, sorry. So the second step is equate it to 0. So f dash of x equal to 0 implies 3x squared minus 27 equal to 0, which implies 3x squared equal to 27, which implies x squared is 9. So x is plus or minus 3. That means f dash of 3 will be 0 and f dash of minus 3 will also be 0. What it means is at the points 3 and minus 3, if I draw a tangent, it will be a horizontal line. So let me draw line here. Let me write minus 3 and let me write plus 3 here. Please understand this is a real line, so always the smaller number will come to the left hand side of the bigger number. Okay, now what next? Very simple. I'll take a value above 3. Let's say, let me take 3.1. We can even take 4. Let's say, let me take 4. So f dash of 4 is, I will substitute it here, 3 into 4 square minus 27. So you will basically get 48 minus 27, which is 21, which is positive. So it means that f dash of x is positive here in this interval. In this interval, f dash of x will always be positive. Okay. Now let me take a value between minus 3 and 3. So let me take 0. So let me take 0. I'll find f dash of 0. So f dash of 0 is 3 into 0 squared minus 27, which is minus 27, less than 0. That means in this interval, whatever x you take, and if you substitute in f dash of x, it will always be negative. Okay, so let me take a value now less than minus 3. Let's say minus 4. So f dash of minus 4 is 3 times minus 4 the whole square minus 27. Again you will get the same answer, 21, positive. So here f dash of x is positive. So you can see here, students, that between here and here, f dash of x is positive. What it means? What does it mean? It means in those intervals, f of x is increasing. So f of x is increasing in minus infinity comma minus 3 union 3 comma infinity. Now you can see here in this interval, f dash of x is less than 0. That means f of x is decreasing in the interval minus 3 comma 3. So this is the answer. In fact, I would recommend that you can plug this function in your GDC and cross-check yourself whether this fact that the function is increasing in these intervals and the function is decreasing in this interval is true or not. Definitely it will be correct, students. Okay, so I'll stop it here so you can solve more problems on your own and then find out. So this is basically the way to find, this is how you find like whether the function is increasing or decreasing. Yeah, thanks for watching this video, students.